Okay. In this short video, we are going to talk about three interesting virtual instruments. The first one is matching parts, and the second one is how to extract an annular circular shape and find its coordinates. And the last one is also related to circles detection and finding their parameters. So we begin with matching a part. This is related to pattern matching. As you remember, we have discussed some examples about this topic. So here is the block diagram. And as you see, we have two important functions to work together. The first one is how to learn pattern function. And the other one, IMAQ Match Pattern. It is given number 4. The output and the result of learning the pattern is fed to the IMAQ Match Pattern, which gives the number of matches if there is matching and the score of matching also. In order to learn the pattern, as you see, we need to extract the region of interest from the image and to input it to the IMAQ learn pattern. It is as a template now. And this template information is given at the output through a report, and also the output image is fed to the IMAQ match pattern, as you see in the block diagram. For safety purposes, we used IMAQ clear overlays at the beginning after having the image, after reading the image, and feeding it to the IMAQ extract number 2. Other elements are known for you. The last element here is a specific sub-VI, which is used in order to surround the matching parts by a square to show you which parts are matching the template. As you see here, this is an image where we have different parts. We select one part to be a template, and the program works out and finds that we have only 2 parts matching the template, the original template and one more. Also, it gives you this information in a written form. Number of matches is given equal to 2. You are supposed to expect the number of matches. So number of matches requested, this is given by the engineer. And the minimum match score you expect, you allow from 1,000. Here it is about given 750, it is good. Number 800, 750 is very normal. Here, as you see, we get information from the matches, about the matches, and about the coordinates of the matching elements. Here, the coordinates 1, 2, 3, 4 are the angles or the angle points of the surrounding rectangle. 1, 2, 3, 4 angles. And here is the other one, 1, 2, 3, 4 points. These are the coordinates of these points. This point, if you look at it, maybe it is seen, yes. Now it is about 33, 195. If you go there, it will be 32, 192. It is the same coordinates. If you come to this one here, the coordinate of this point, not seen enough. Now, 537, 141. There it is, 535, 139. They are very near, practically the same. So what you are going to do is nothing, just to run the program, and you draw the rectangle of interest, which defines the region of interest, and now this will be taken as a template, and when you run OK, you will have got the answer. Now these two are surrounded by rectangles, and the number is shown as 2, and the score is 750, and that's it. If we try to select one part, which is the only one in the image, like this screw, for example. So when we run the program, and we have this screw, we surround this screw by the rectangle and accept it as a template. So we have only one element matching, and concerning the results and the readings, here we have one number of matches is equal to 1. Well, I think it is enough to talk about this. It is clear for you. Let us move to another program. The second program is how to extract a circle and put it in an individual graph alone. As you see here, we have this bracket. We have this circle. It is our target now. We want to make a template of this circle and put it aside in a specific graph alone here. So the program is not that difficult also. We use IMAQ Find Circular Edge 3 function. The input is the image of the bracket itself and the region of interest. And here, of course, the coordinate system is not required to introduce anything about it. And you have to define the system modes. Get first edge is our interesting mode. And here is the output. Now, this function gives, as you see here, a cluster. This cluster is unbundled, as you see, in order to get the values of the XY coordinates of the circle, which is extracted, and its radius. Having them, we can define 4 points at the perimeter of the circle, represented as an array, and this array is fed to the extract function here in order to extract the image. So the extracted image practically is this one. This is the extracted image with the, of course, you know, the coordinates by eye. And as you see here, we have these black corners, which are not of interest for us. What I have done, I have inversed the output through IMAQ inverse function, and we got exactly the circle, as you see, with its coordinates seen by you. The values of the radius and the XY values of the center are given here. They are shown from the block diagram here. We know this is X. I know I took a terminal here indicator, and I took a terminal as the Y indicator. Also, I have an indicator for the radius, and I can work with them as I want. So we can read the values of the parameters of the circle, as well as we have the circle alone as a template. Remember also the values of the circle is 59.5 or 0.6 in pixels, which is equal to the numbers which we have got before through other examples. There is no difference between the results. And concerning the center coordinates, of course, you can be sure of that by considering the results by putting the cursor in the center here and reading it. By me, it is 364, 200. There it is 365, 202. It is exactly the same, no difference. The difference is not in calculation. The difference is due to the positioning of the pointer in the exact position here. Okay, with these two examples, I finish this video, and I will see you hopefully in the coming video very soon. Goodbye.